Okay, Year 12, here is the work we did today on further applications of de Moivres theorem. So what I'm going to do is I'm going to start with the work we did today and see if you can use this to do your homework. So let's start with what we've got to do. We've got to write cos 3 theta in terms of a single theta. So now we know we can do that because we know, well, that's the same as cos 2 theta plus theta. We know our double angle formula, which is cos 2 theta cos theta minus sine 2 theta sine theta. And we then go through that process again because cos 2 theta is cos theta plus theta times cos theta, and sine 2 theta is sine theta plus theta sine theta. And we use a bigger set of brackets this time, so cos theta plus cos theta is cos theta minus sine theta sine theta. We get cos theta times that minus, well, sine theta plus sine theta is sine theta cos theta plus cos theta sine theta, and that's times sine theta. We'll just tidy that up. Well, that's cos squared theta minus sine squared theta times cos theta minus 2 sine theta cos theta times sine theta. And this should look familiar. Now I can get it all in terms of cos because I started with cos. And that's what I'm going to do, which is, I think, different from the back of the book. If I just have a quick look. I can't remember how Patel did it, but I want to try and make it the same. So here we go. And Patel did he leaves it in sine. So we'll leave it like this. We'll leave it in this manner. So that'll give us, when we expand this, cos cubed theta minus sine squared theta cos theta minus 2 sine squared theta cos theta. Well, that'll give me cos cubed theta minus 3 sine squared theta cos theta. And that's where Patel leaves it. I'm going to go one step further. I'm going to change that sine squared theta to a 1 minus cos squared theta. Watch what happens if I go cos cubed theta minus 3, and I've got 1 minus cos squared theta by cos theta. Well, that gives me cos cubed theta minus 3 cos theta minus cos cubed theta, which gives me cos cubed theta minus 3 cos theta plus 3 cos cubed theta, which is 4 cos cubed theta minus 3 cos theta, which is the answer we got in class. Now, that's a lot of work, and you're going to have to do it for cos 4 theta and sine 4 theta and tan 4 theta. There is another way. So let's use Moivres theorem. So let's start with this. Let's start with cis 3 theta. And if we apply this, well, we know by Moivres theorem, well, that's cis theta cubed. And over here, we'll quickly do Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's as far as we need to go. And we know that if we go over here, that's cis, well, that's cos theta plus I sine theta, all cubed. So if I go back to here, that's 1 a cubed b, oh sorry, no b in there. And that's 3, the first thing squared, and the second thing to the power 1, and that's 3 a, whatever the second thing, b squared, and that's b cubed. They're all plus, and that's the expansion of something plus something, all cubed, that binomial expansion. And that's what we've got here. This is our A and this is our B. So we can very quickly go, okay, I'm going to get 1 cos cubed theta plus 3 cos squared theta times I sine theta plus 3 cos theta I squared sine theta squared plus I cubed sine cubed theta. All right, well, the cos cubed theta, that's just going to stay. We've got cos cubed theta. Now, this I squared is going to become negative. I'll just write this out. So plus 3 cos squared theta sine theta. Sine theta I. And that's going to become minus, because I squared is minus 3 cos theta sine squared theta. And this is going to become minus I, because I cubed is minus I. So I'm going to get minus sine cubed theta I. Now, if I put the real parts together, so this bit and this bit, and if I put the imaginary parts together, so this bit and this bit, we'll see what we get. So we get cos cubed theta minus 3 sine squared theta cos theta plus 3 cos squared theta sine theta times I minus sine cubed theta times I. And now I'm just going to write this out completely now. Cos cubed theta minus 3 sine squared theta cos theta plus I outside of 3 cos squared theta sine theta minus sine cubed theta. Okay. And we know that this is the same as cis 3 theta. And cis 3 theta is cos 3 theta plus I sine. And that's a bit messy. I'll tidy this up. Cos 3 theta plus I sine 3 theta. Now, if they're equal, well then the real parts should be equal, and so should the imaginary. So cos 3 theta should be equal to that. And sine 3 theta will be equal to, or I sine 3 theta will be equal to what goes with the imaginary part. And we already know that. If we look back up here, look at this bit. Cos cubed theta minus 3 sine, and it is. It's the same. And this one, we get 2 for the price of 1. We get cos 3 theta and sine 3 theta. So this is equal to cos 3 theta, and this is equal to sine 3 theta. And it's not as much work as the other one, especially if we're doing 4 theta or 5 theta. Now, there's one more bit that we have to do, and that's tan 3 theta. So let's have a go at tan 3 theta. So tan 3 theta. Well, what does that equal? Well, tan 3 theta is sine 3 theta over cos 3 theta. Well, I've got those two, so let's write it out. We'll put in 3 cos squared theta sine theta minus sine cubed theta all over cos cubed theta minus 3 sine squared theta cos theta. Now, what I'm going to do now is a little bit of a trick. I want it in terms of tan. So I'm going to divide everything by cos cubed and watch what happens. So on the top, so I'm going to divide the top over here. I'm going to divide everything here by cos cubed and everything on the bottom by cos cubed, which won't change anything. I'm dividing top and bottom by the same number. So on the top, I get 3 cos squared theta sine theta over cos cubed theta minus sine cubed theta over cos cubed theta. And that's the numerator. There's my vinculum. Now let's do the bottom part. I've got cos cubed theta over cos cubed theta minus 3 sine squared theta cos theta over cos cubed theta. Okay, well, let's look at the top. Cos squared theta is going to go with one of those, which leaves me with 3 sine theta on cos theta minus, well, I've got sine cubed theta on cos cubed theta. Well, that's just tan cubed theta. My vinculum. And on the bottom, I get cos cubed that's 1. And here, I do a bit of cancelling again. Cos goes there and gives me cos squared, which is really handy because I get 3 sine squared theta on cos squared theta. We're almost there. So now, well, sine theta on cos theta is tan theta, so I get 3 tan theta minus tan cubed theta all over 1 minus, and that's sine squared on cos squared, so that becomes tan squared theta. And that's the right answer. So what you need to do now is go and do that for the same things for 4 theta and 5 theta. And using de Moivres' theorem gives you 2, both cos theta and sine theta, by equating the real and the imaginary parts. It gives you 2 of them with the amount of work for 1, possibly even a little less. But remember, you're going to have to do Pascal's triangle a bit further. You're going to have to go down to 4 and 5. So you're going to have to go all the way down to there. Good luck.